Hello everyone, and welcome to the channel. For hundreds of years, people dreamed of doing something that seemed impossible. Turning an ordinary metal into gold. Ancient alchemists spent generations searching for a mysterious process that could transform common materials into one of the world's most precious metals. They never succeeded. But today, modern science has achieved something remarkably close to that ancient dream. Scientists can actually transform atoms of one element into atoms of gold. So, if science can create gold, why aren't scientists producing mountains of it? Why can't we simply manufacture gold in factories? And why does gold remain one of the world's most valuable metals? The answer takes us deep inside the atom, where chemistry ends and nuclear physics begins. To understand this, we first need to understand what makes gold, gold. Every chemical element is defined by the number of protons inside the nucleus of its atoms. Gold has exactly 79 protons. Lead, another heavy metal, has 82 protons. That difference may sound small. Just 3 protons. But at the atomic level, those 3 protons separate 2 completely different elements. And this is where the ancient alchemists faced an impossible challenge. Ordinary chemical reactions can rearrange electrons and change how atoms bond together. But chemistry does not normally change the number of protons inside an atomic nucleus. To truly transform one element into another, you need something far more powerful. You need nuclear transmutation. And modern nuclear physics has shown that this is possible. In 2025, scientists working with the ALICE experiment at CERN reported fascinating measurements involving lead nuclei at the Large Hadron Collider, or LHC. The LHC is one of the world's most powerful particle accelerators. Inside this enormous scientific machine, lead nuclei can travel at speeds extremely close to the speed of light. During certain near-miss collisions, the incredibly intense electromagnetic fields surrounding these nuclei can interact. Under these extraordinary conditions, a lead nucleus can lose protons. And remember, lead has 82 protons. Gold has 79. When the nuclear transformation produces a nucleus with exactly 79 protons, gold has been created. In a scientific sense, humanity has achieved something that ancient alchemists could only dream about. We can transform one element into another. And we can produce gold nuclei. But before you start imagining particle accelerators replacing gold mines, there is one enormous problem. The amount of gold produced is unbelievably small. According to CERN, during the LHC's run from 2015 to 2018, the relevant processes produced an estimated 86 billion gold nuclei across the 4 major experiments. 86 billion may sound like an enormous number. But atoms are extraordinarily small. All of those gold nuclei together represented only about 29 picograms of gold. A picogram is 1/trillionth of a gram. And there is another problem. This newly created gold does not emerge from the machine as beautiful gold bars. The gold nuclei exist for only an extremely short time before they strike accelerator components and break apart. So, while the experiment demonstrates something scientifically extraordinary, it does not provide a practical method for manufacturing usable gold. And this brings us to the question of money. Could scientists build a machine specifically designed to manufacture gold and become incredibly rich? With today's technology, the economics simply do not work. Particle accelerators are extraordinarily sophisticated machines. They require advanced engineering, enormous infrastructure, highly trained scientists and engineers, and substantial amounts of energy. Producing an incredibly tiny quantity of gold through nuclear processes would cost vastly more than the economic value of the gold itself. In other words, science can make gold. But making gold this way is not a practical business. And that helps explain why gold remains valuable. The world's usable gold supply still comes overwhelmingly from mining and recycling. Gold is naturally scarce. Extracting it requires significant resources and investment. At the same time, demand for gold comes from many different areas. People buy it for jewelry. Investors use it as a store of value. Central banks hold enormous gold reserves. And gold is also used in electronics, aerospace, medicine, and specialized technologies because of its unique physical and chemical properties. Modern nuclear science has not changed this economic equation. The microscopic amounts of gold created through nuclear transmutation are simply too small to meaningfully increase the global supply. And gold's recent price history shows just how valuable the market still considers this metal. Gold prices have risen dramatically over the long term, although they do not move upward continuously. Prices can rise. And they can fall. In early 2026, gold reached extraordinary record levels, briefly climbing above $5,000 per troy ounce before later retreating significantly from those highs. That volatility reminds us that gold is still a globally traded asset whose price responds to economic conditions, interest rates, inflation expectations, geopolitical uncertainty, investment demand, central bank purchases, and many other forces. But there is an even bigger question. What happens in the future? Could humanity eventually develop a technology capable of manufacturing large quantities of gold cheaply? In theory, if a revolutionary technology could produce enormous quantities of gold economically, it could dramatically increase supply and potentially affect gold's market value. But with the technology available today, we are nowhere close to that reality. The difference between creating a few fleeting gold nuclei in a particle accelerator and producing kilograms or tons of stable, usable gold is enormous. And that is perhaps the most fascinating part of this story. For centuries, alchemists dreamed of turning ordinary metals into gold. They searched for secret formulas and mysterious substances. They never found them. Because the solution was never hidden inside ordinary chemistry. The answer was hidden much deeper. Inside the nucleus of the atom. Centuries later, nuclear physics finally demonstrated that one element really can be transformed into another. Humanity has, in a scientific sense, achieved the ancient dream of creating gold. But there is a remarkable twist. We discovered how to make gold. Only to discover that producing it artificially is far more difficult and expensive than simply obtaining the gold that already exists on Earth. So, for now, gold remains precious. Not because science is completely incapable of creating it, but because science cannot yet create meaningful quantities of it efficiently and economically. Perhaps one day, new technology will change that. But until then, the dream of turning other elements into gold has become scientifically possible, while the dream of getting rich by doing it remains far out of reach. If you enjoyed this journey through science, history, and one of humanity's oldest dreams, please like the video, share your thoughts in the comments, and subscribe to the channel for more fascinating stories about the elements, materials, and discoveries that shape our world. Thank you for watching. And I'll see you in the next video.